Hello guys, my name is Bhupesh Asu and today we are talking about delta communication or delta modulation. Now delta modulation is one of the important part of this PCM module. Whenever we are talking about the pulse code modulation, delta modulation is a kind of improvement over the normal PCM. Now in the normal PCM, what is the problem is every now and then whenever we are transmitting bits, all the bits needs to be transmitted. If you need to transmit all the bits, then the problem occurs, and due to that problem, the signaling rate and bandwidth will be quite large. So how to rectify that problem? In delta modulation, what you are going to do is we are just introducing a new technique that we are taking one bit per sample, and that particular bit will be transmitted to channel. Now whenever we are transmitting this particular bit, how you are going to transmit that bit and how you are going to understand that how that bit is different from the previous bit. So what is the best technique is we just understood that every proper channel, every proper signal will be distributed or divided into multiple parts, and every part is compared with the previous part. Now if you are comparing one part with the previous part, there will be a slight change. If there is no change, like this one, this is the signal which is actually moving. Now step size will be decided. So what will be step size? It is defined by quantization. Now in every size you are comparing with it with the previous sample. If previous sample there is a change in particular signal or change in step size, you are going to put 1. If there is a decrease over there, you are going to put 0. So that is how you are going to communicate. You just need to understand that every sample size, every sample signal will be actually compared with the previous symbol. Now previous signal is actually on the lesser side and it is increasing, then you are going to write it as 1 unless it is at 0. Now what is the technique that is used in this delta modulation is this. Like this is the signal. Now this signal, 1 bit quantizer is used and 2 summer is used. This particular circuit is used to compare that particular signal with the previous step. Now there will be a delay, and this is mu n minus 1 ts. This mu n minus 1 or un minus 1 ts is the previous step signal sample, in which you understand that a particular signal was there and the value is decreasing or increasing will be added to that. There will be a delay, and again this value has been put up over there. Now this summer will actually compare both the inputs. If current signal is actually higher or is increasing than the previous signal, then you are going to put 1 unless you are going to say 0. Now how you are going to write it in equation part? So there must be equation to understand this one. First, you need to understand that this is a 1 bit quantizer. This is the previous signal, mu un minus 1. This is the signal actually. This is this one, xt, the modulating signal. Now, every now and then you are comparing it at this step size with the previous step size. If previous step size is decreasing, then you are going to put 0 like this. Here it is decreasing, they are going to put 0 unless they are going to put 1 over there. If it is increasing, here it is increasing. If it is increasing, you are going to put 1 over there. So this is how you are going to implement it. In equation part, you will write it down the equation first. So what will be the solution of this one? How you are going to compare it? And what will be the delta receiver in this? Now suppose if you want to check the error, so if you want to check the error, E and TS will be X and TS. Here this is just the same particular signal. It is represented by this format and X bar and TS. Now X bar and TS is the previous step in which that signal or quantity has been evaluated. Now if you are going to check it, this error, so if you are going to put it, X and TS can be write down as U n minus 1 TS. Previous signal, it can be represented by this one. If NTS is the current signal, so n minus 1 TS is the previous signal. Now if you want to put it, the quantity beat NTS, it needs to be defined, will be delta sign E NTS. Now how this quantity is actually measured? You are just comparing with the previous one. This is how you are going to measure it. B and TS is the delta sign E and TS. Now it will be a positive or negative. It will be based upon the increasing or decreasing. If it is increasing, it will be a plus sign, and if it is decreasing, it will be a negative sign. Now to put it this equation, P and TS equals to plus delta and minus delta. If X and TS is greater than X cap and TS, and if X TS is less than X cap and TS. So this is how you are going to solve it. Now there are two conditions and two results, plus delta and minus delta. So you got two signs, two step size, and now whenever you got plus delta, that particular bit will be represented by 1. Whenever you have minus delta, that bit will be sent as 0. That binary bit will be sent as 0. So this is how you are going to do it. This is the part of delta modulation. I have already shown you in the signal part how you are going to represent it. Every signal, whenever it was decreasing and increasing, whenever it was increasing, you are going to put 1. Whenever it is decreasing, you are going to put 0 over there. Now this circuit is called accumulator. This circuit is called accumulator, and in here, if you are talking about the sample representation, so it can be written as U and TS equal to U and TS minus TS plus minus delta, or in the right form, U and TS I just put the value there, and B and TS is plus delta and minus delta based upon your previous signal. So U and TS can be written as U and minus 1 TS plus B and TS. So this is how you are going to represent it. In receiver, this is the transmitter circuit. This is the transmitter circuit. Now in the receiver, what you are going to do, this signal will be transmitted over a channel. Now in the receiver side, what you are going to do is this particular signal will be sent to an adder. With the delay circuit TS, and then to LPF. At the receiver side, what you're going to do is, this is the transmitter side, the channel will be there. Now there will be an adder. This output of this one is written over there. Again, this output of this one is actually being delayed and again added to this one and pass through low pass filter. After passing through low pass filter, you will get the actual signal, because by then you will actually get the comparison. If it was a plus or minus, plus delta or minus delta, you can understand them and you can just compare them accordingly. So this is how you're going to do this. Now there are some drawbacks in delta modulation, but first you need to write it down, both the things, what are written on the board over there. Thank you guys. Now we will talk about the advantages of this delta modulation. Whenever we are talking about the advantages, we are sending only 1 bit per sample. So there will be a lesser signaling rate as well as the lesser bandwidth requirement for this communication. And the second thing, there is no complex circuit. You don't need data analog to digital converter. Every now and then in normal PCM you have to use analog and digital converter, but in this particular type of modulation you don't need this. But there are certain disadvantages which needs to be discussed. So 2 disadvantages are discussed and actually asked in the exams quite frequently. The first disadvantage of this system, I'm sorry for the last time when it was not visible over there. Actually in the receiver side, what you're going to do is, there will be an adder. This signal will be gone to the adder and there will be a delay circuit by TS, and the output of that has been sent to low pass filter. It was not visible in the last time, so I just need to put it over there. If you need to write it, you can actually note down and draw it in your notebooks. The second important thing is the advantage and disadvantage. They are going to ask you about the circuit, they are going to ask you about the advantage, disadvantage, and how to overcome the disadvantage by using adaptive delta modulation technique. Now we are going to do is we are going to discuss the disadvantage of delta modulation. So this what is the most drawback of this particular thing is the first is slope overload distortion. I am writing down on the board first and then I will explain to you. There are 2 disadvantages. There are 2 disadvantages. The first one is called slope overload distortion. and the second one is granular noise. Both the disadvantages can be rectified by using different techniques. The second one is granular noise. The first one is slope overload distortion. Now every now and then there will be a slope in particular signal, and that particular slope will be defined by the incoming voice value. Now this voice value is actually analog signal, and that analog signal is bound to change its value every now and then. Like I can raise my voice like this, or I can actually speak very calmly. So that is the way you have to understand that particular voice signal will be changed. Its different modules will be there, and different modulations will be there. So there is a possibility of slope overload distortion. So what is happening is, it is happening due to large dynamic range of input signal. Now I would like to draw one figure out there, like this one. Now this is the signal. Now this is the signal which we already know of. Now if you're talking about the signal, this signal is like this. Now this part, if you are seeing this part, this whole part, it can be highlighted using the blue marker. I am going to highlight using the blue mark. Now this part is slope overload distortion, and over here the next part is granular voice. Now granular voice, I am going to show it with green. Now this is granular noise, and this part is slope overload distortion. Now we will understand the meaning of both the things. You just need to draw it first. Now if you are talking about this signal is, this one is the XT as usual. This one is the step size, if you are talking about this one, delta. If you are talking about this one, this is your TS, sampling time. Now this one or this one, this is also granular noise. Now this part is granular noise, though I didn't draw it with green one, but yes, this is the granular noise. And this part where this slope has been created, now this slope has been created in such a manner, but yes, it is increasing in this manner, and there are step size over there, so there will be an extra slope, and this is called slope overload distortion. Now what is happening is, the rate of input is this one, xt is so high that the staircase signal cannot approximate it. Now this one is the staircase signal. It is every now and then it is just approximating it. Now there is this overload where it is not been able to approximate it. If it is not been able to approximate it, then this is called slope overload distortion, and this is quite frequent in delta modulation. Yes, we can actually rectify it. Now this error or noise is called slope overload distortion, and step size is remains fixed. So maximum or minimum slopes occur along straight lines. It is also called LTM. linear delta modulator. Why we are calling it linear delta modulator? As we are not changing this step size, so approximation of that signal will not be altered, it will remain fixed. So whatever particular time you are choosing to actually get the signal in a particular manner, and the step size will remain fixed throughout the course of that signal. So they will not be changed, so it is called linear delta modulation. And this extra part, because it is not changing accordingly and it is remain fixed, so this is called slope overload distortion. And next time, and the next thing which is the disadvantage of this particular modulation is this granular noise. Now here it is decreasing, but there is a difference between this step, approximation step, and this input signal. Now there is a change and we are not being able to completely overhaul it. So what is happening is, this is called granular noise. It is the inherent property of this particular signal. So there are two types of things. In exam they are going to ask about this slope overload distortion. Whenever they are going to ask is, due to this fixed step size and you cannot change the approximation, the slope which is actually overhead to this particular steps is called slope overload distortion, like this. And whenever it is going upside and the extra part is there available to you, then it is called granular noise. Both the parts are the part of this delta modulation. Now in the granular or idle noise, this is called idle noise. This idle noise is also presented in delta modulation. Now in delta modulation, what is happening is, what you are going to do is, step size is too large compared to the small changes. Now step size is too large compared to small changes. What is happening is, here too much noise was there because it was overload and approximation cannot be done, and there was a large change over there. But when delta is too large and small changes are occurring, what will happen then? Then that particular distortion or noise is called granular noise, and this is the error, and it can be calculated by input and minus approximated signal. Now this is happening due to large particular signal quantity, and this is happening because there is a small changes occurring. So both the things are done in delta modulation. So what you are going to do is, you are going to introduce a better modulation, and that is called adaptive delta modulation. In adaptive delta modulation, you just change a small method, and then you are going to do it. I am going to tell you about this adaptive delta modulation in this class only. So just note down both the noises, disadvantages of this delta modulation, and we will know about adaptive delta modulation. Thank you guys. Now we will talk about the adaptive delta modulation. As we know, in delta modulation there are two distortions out there, two disadvantages of delta modulation. The first one is the overload distortion, and the second one is this granular distortion. So one was created because step size was too, so we're not accommodating large changes, and the second was actually occurred because it was not accommodating the small changes. So what we can do is we can just adapt it. Whenever there is a changes in particular step size, now step size will be changed. The signal is, if it is signal is changing and the change is completely large, if it is large, then it can be changed, step size will be changed. And when it is not changing so much or the change is so slow, we can actually reduce the step size. How we are going to introduce such kind of methodology in delta modulation? So first what we are going to do is, it is almost the same circuit, but what we are going to do is we are using logic control method. This logic control is actually accommodating the change in step size due to that change in particular signal's amplitude. Now if there is a large amount of change occur, then what we are going to do is we are going to introduce the differential step size. This is how we are going to do is this input. Actually this input is, again, if 1 bit quantizer's output is high, then step size will be double due to this logic, and if it is low or lesser, then this step size will be reduced by one step. One step lesser step size will actually accommodate the small changes or no changes at all. So basic circuit remains the same, but the difference is this logic control actually been introduced in this particular circuit. Now this circuit is again called accumulator. Now whenever we are saying this circuit is called accumulator, and this circuit is used in both transmitter as well as in receiver. So in receiver, what you are going to do is you are going to put here is the input or output of this one will be there. Actually the logic will be provided to it, and both the inputs will be passed through logic, and it is multiplied by this circuit. Now the output of that multiplier will be provided with the delay, and it will be provided to again accumulator circuit. This is accumulator. This accumulator circuit, it gives us the idea whether the step size increase or decrease, and output will be passed through low pass filter, and you will get the better output. Now what is the advantage of this adaptive delta modulation? You can actually choose the step size according to your variance. If there is a very particular variation available in the input signal, you can actually change the step size. So by changing the step size, you are literally removing all the noises available in that, because large amount of noise was presented due to that large amount of changes, and small changes was available in granular noise. So both the factors has been actually been quantified and actually been rectified in this particular circuit. In the next part, we are going to talk about the differential PCM. Differential PCM is actually the better methodology for this adaptive delta modulation. Literally, adaptive delta modulation is one of the best technique, but in the DP-CPM, you are getting the better distortionless signal. So we are going to study that particular DP-CPM in the next class. Today we are done with it, and this is how we are going to do it. Now if you can see this, you have already seen this one, but we have to understand how it is variation is available. Now if you see this, here step size has been doubled, literally doubled, because there is large amount of changes available to there, but here it was reduced. So every now and then you can actually check the step size of that particular signal, and you can get the better comparison. So this is how we are going to do analog to digital communication and this is how you are going to convert a signal into digital signal. And now this digital signals can be actually retrieved at the receiving side using this particular circuit. Thank you guys. Bharat Mata ki Jai. Stay home, stay safe, and use your mask quite frequently, because corona is still there, and you need to understand that this pandemic can only be faced by using all these techniques, measures provided by the government of India. Thank you. Jai Shri Krishna.